Hey, everybody, come on in. Come on in. We'll give it a minute for everyone to come into the room, and then we shall begin. Okay. So we'll give everyone a second to come in and join in. Good ones. Cool. And we shall begin. Okay. Hey, everybody. Welcome to another episode of Gnarly Dataways, episode 59, How the Time Flies By. Again, Gnarly Dataways is presented to you by Dremio. My name is Alex Merced. I am your host, and we got an exciting episode today talking about charting the course, the evolution and future of Apache, Iceberg, and Polaris. Basically, we will have this talk from my good friend and Apache Software Foundation board member, Jean-Baptiste Onofre. We'll be bringing him on in just a moment. But before that, we got always some fun announcements to make as we get things started. And of course, I always want to encourage you all to subscribe to Gnarly Dataways, the podcast version, so that way you make sure you never miss an episode. You can do that by either subscribing to the YouTube channel at youtube.com/Dremio, or you can head over to Spotify or iTunes and subscribe to the Gnarly Dataways podcast feed and get these episodes when they are shared on the podcast feed. And again, we are Dremio. We are the unified lakehouse platform for self-service analytics. The idea is we make using your data lake as your data warehouse easier, in three pillars of value. One, whether it is unified analytics, our ability to federate queries across your data lakes, your databases, your data warehouses, be able to do that very quickly, leveraging things like Apache Arrow and other technologies, and our reflections to give you a really fast query service with our very powerful SQL query engine that works with your data that's on-prem or in the cloud. But when you're running a data lakehouse, oftentimes you got to manage those tables. And unlike a database or data warehouse where that stuff kind of happens automatically, you kind of have to have the setup. And that's one of the things where we can help you out with, where we can help automate a lot of that table maintenance, whether it's compaction of tables to make sure that those tables are performant when they are queried, or snapshot expiration to make sure that any excess unnecessary files are cleaned up from your storage when they're no longer needed. We can help automate those processes. That way your data lakehouse tables, well, just work. With that, one of the best ways to kind of get hands-on with Apache Iceberg, with Dremio, with all these things is through these tutorials that'll help you set up a lakehouse environment on your laptop. So by scanning these QR codes, you'll find these tutorials. You can quickly spin up some Docker containers to actually have a full lakehouse operational on your laptop to actually get hands-on and see what the end-to-end experience is. You can always find all of this and much more over there at the Dremio blog at dremio.com/blog. Speaking of Iceberg, I always encourage you, if you haven't already, to pick up Apache Iceberg, the definitive guide, basically the definitive guide on Iceberg. You can scan this QR code here to get yourself a free copy. It's a free PDF copy of the final manuscript. Check that out. You can learn a lot from reading it. But not only do we have this knowledge in book form, you can also take a course. We do have an Apache Iceberg course that right now we're at the tail end of the live run of these sessions, but you can still watch all these sessions on demand, and you can register for that by scanning this QR code right here. All sorts of ways to learn more and more about Iceberg, one of our favorite topics. But with that, no further ado, let's get on to our featured presentation of charting the course, the evolution and future of Apache Iceberg and Polaris. And with no further ado, I'd like to introduce Jean-Baptiste Onofre, a board member of the Apache Software Foundation. JB, the stage is yours.
Yeah, thank you, Alex. Appreciate it. Let me share my screen. Here we are. So yeah, thanks, Alex, and welcome everyone for this quick introduction about Apache Iceberg and mostly Apache Polaris, which is an incubator project. So quickly, as Alex said, I'm a ISF board member. I'm JB, so PMC committee on 20 Apache projects. Also mentoring some podling. So the podlings are basically the project into the Apache incubator. So I'm mentoring and also champion on Apache Polaris. I'm contributor on Apache Iceberg, and obviously I'm principal software engineer at Dremio. So to provide some context about Iceberg and Polaris and where they are located in the data lakehouse architecture. So on the bottom there, we can see the storage, which is really both the file system, the object storage, but also the data file. So basically the Apache Parquet file, the org file, whatever. On top of that, we have the table format, which is basically by adding metadata on top of the data files, we have additional semantics and structure of the data file as tables from a SQL semantic. On top of that, we have a query engine. So basically, the query engines are executing queries, obviously, on the table format. And to do that, they are not directly accessing the table format. They are going through a catalog. So the catalog is basically, hey, I'm a query engine, give me the metadata for these tables. So we give a table name, and the catalog returns basically the location of the metadata file required by the query engine. The query engine is basically using all these metadata to create the plans and optimize the queries to retrieve the data. So that's basically the data lakehouse components we can see. The table format is obviously Apache Iceberg, and the catalog is obviously Polaris. So that's the two components we're going to talk today. So let's go into the table format. So the table format is basically Apache Iceberg. So Apache Iceberg is a table format specification first. So basically, Iceberg provides all the specification and also a set of APIs and libraries to interact with this specification. So there are some users that directly implement their own kind of libraries using directly the specification. So instead of using directly the API and libraries from Iceberg, they are implementing their own. But most of the time, the query engines and users are basically taking a look on the specification, but they are using the specification through the APIs and libraries provided by Iceberg. So Iceberg is not a storage engine. It's not an execution engine either. So it means that basically it's a set of libraries that the storage engine or the execution engine has to support and implement. So on the bottom, we have the data files. These data files are located on a storage. So most of the time is an object store like S3. And the data files are, I would say about 95% of the time are basically Parquet file. Iceberg is also supporting org, but to my knowledge, only mostly Parquet is used. On top of that, so you have a bunch of data files there. On top of that, we have manifest file. So the manifest file is adding, this is the list of the data files that is a table, basically. So the manifest file describe the access of the data files and group and add the semantic to create a table or a view on top of these data files. On top of a manifest file, you have a manifest list, which is basically a way to create some kind of snapshots and group a manifest file. And all these gather in a one big file, which is the metadata.json. And this metadata.json contains all the snapshots for one table. And each snapshot is contains manifest list, and manifest list contains manifest file extra. So this metadata.json is basically what the catalog returns to the query engine. So basically the query engine goes to the catalog. He said, hey, give me the metadata.json for db1.table1. And so the catalog knows the pointer to the metadata file, which is the metadata.json, and return this to the query engine. So this approach, adding metadata on top of a data file, provides a lot of interesting features. The first features is basically consistency guarantee. So it means that when you write into a table, it's gonna advance the snapshot, you're gonna update the metadata, but all in the same transaction. So you have a consistencies guaranteed when you write into a file. So basically that's what explains. I have a catalog, I have my engine, the engine is requesting, okay, give me table A metadata. So you can see that the catalog will return this location for the metadata.json. So that's basically the core role of the catalog, is both to maintain this pointer, and by using Iceberg, you have a guarantee. So basically an ACID kind of transaction when you write into tables. Another good feature about metadata is you have about the schema evolution. So the schema itself is stored in the table metadata. So all about schema partitioning, everything is not on the data file, it's directly on the metadata. So it means that you can move forward on the evolution on the schema. So basically you can add the new columns or you can change a column, and it's going to be stored in the metadata, meaning that you can have different schema over time without changing your data files. All stay in the same state for the data. Another thing is, I talked already about little in this slide. You can see schema evolution, but also mentioning partition. So partitioning is a way to know that you don't need to read all the data files to get exactly the data you want. So basically, the query engine is going to use the metadata to say, okay, this is how my data files are partitioned. And so depending on this partition, I know if I have to read those files or whole files or a subset of files. So less we read, better the query gonna be. So faster and cheaper. That's basically the purpose. So in Iceberg, you can have different partitioning. So you can have multiple partitioning per table. So you can define a partitioning per month or per day or whatever. So the purpose is really to optimize the queries by limiting the number of data files we read. So this is an example about partitioning and evolution of a partition. So you can see that I create a first table, catalog db.table1, that contain 3 columns. And I said that I partition this table per month. So I'm using a transform, which take the timestamp and create a partition per month. So this is the first blue boxes you can see there, where I have this partitioning. And later, I had a new partition, which is per day. So I have 2 partitioning scheme. I have month, and later I have D1, T2, D3, which is another partition scheme, which is pretty cool because you don't have to change your existing partition to add new partitioning. It can adapt to your use cases. And on each table, you can have multiple partitions. That's not a problem at all. Another cool feature is hidden partitioning. So sometimes in the past, when you used Apache Hive, you have to specify exactly the partitioning. So you can see that I do a SQL query, which contain in the statement, I have my month between 1 and 4. So this is an explicit kind of partitioning. I want to use my partitioning on month. And I explicitly define in my query the sub-partition I want to use. In Apache Iceberg, you don't have to specify the partitioning. You can see there, I only using timestamp and don't mention month in this SQL query. Implicitly, Iceberg and the query engine will know that for this query, it's better to use this partition, and so it's going to use hidden partitioning in that case. So it's more intuitive, meaning that you don't have to care about the partitioning, and it reduces the mistake when you write your query. So some highlights about Apache Iceberg spec. So actually in Iceberg, we have multiple specs. We are not a single spec. We have a table spec. So that's the current. So currently the V2 is the one it has been released, and we are working on table spec V3. And we have another one, which is the REST spec. I will get back to the REST spec later. So on the V3, what we can see, there are new type support that's coming in V3, like a JSON. It means that you will be able to directly store JSON data into columns. We have discussion about positional delete improvement using delete vectors. If you want some details about it, it's currently on discussion. But basically, in a nutshell, it means that we want to store the vector delete in Puffin files to improve and have a better positional delete in terms of fast read and stuff like that. Geospatial support, allowing you to store directly as a column all about geospatial data. Row lineage, which is a way to track all the changes you do on a single row. So basically, on each row, you're gonna have an ID and an increment, so you can see all the changes that are happening on the row. Multi-column transform, use so that when I use the partitioning, I define month with a timestamp, which is a transform with a single argument with a single column. So you will be able to create transform function that use multiple columns. That's a new support. Timestamp in nanosecond, it's a requirement we got from especially financial use cases where they need more detail and not timestamp in second, but more in nanosecond. So that's the table spec v3 that's coming. It's not exhaustive. You have a lot of other things happening, but that's for me the main things we are currently discussing, and that's going to happen in the spec v3. Aside of that, we have a REST spec. So the REST spec is another specification which is part of Iceberg, and we have, so basically it's the catalog REST specification. So we have different things coming on, like a server-side scan planning, which is currently the query engines are responsible to all the planning, but the REST catalog can also do some kind of server-side pre-scan just to facilitate the way of the query engine to execute the query and optimize the time they are spending. So a lot of different things, support for endpoint discovery, which is basically a way to describe what the endpoint is provided by a catalog, meaning that we can define the catalog capabilities using this discovery endpoint. So this is some improvement on the REST spec, also improvement on the authentication, stuff like that. Why I mentioned the REST spec is because we're going to talk about the engine and the catalog now. So as I said before, the role of a catalog is really, okay, give me a table name, and then I return to you the metadata.json. But we can imagine a lot of different features on top of that. So the first role is really a technical catalog, but we can imagine to have lineage, data governance, lazy snapshot loading, multi-table commits, caching, a lot of other feature, which is not directly part of a spec, but it could be something related to the implementation of a catalog. So each catalog define the features they want to expose. So in the past, in Iceberg, we had different catalogs, and we still have these different catalogs, like JDBC catalogs, like the Hive catalog, the Hadoop catalog, extra. So it means that most of the catalogs are related to a single language. I mean, like when you use the JDBC catalog, obviously you have to use Java. But it's more than that. You also have to use some kind of backend. So when you use JDBC catalog, you need an RDBMS layer to store your data. And what we see is in large organization, we have multiple query engines using the same Iceberg storage. So basically, it means that it's not rare to find Apache Spark used on some use cases, Trino used in other cases, and Dremio used in other cases. But so you have a lot of different query engines using the same Iceberg layer. Problem is, each query engine has almost its own catalog. So when I use Snowflake, for instance, I have to use the Snowflake catalog. If I use Athena, I have to use my Glue catalog. If I use Spark, I have different options. I can use Tabular catalog, I can use Glue. If I use Dremio, I can use the Dremio catalog, extra. So it means that we have one engine, one catalog supported. So pretty soon it means that we have a kind of multi-catalog. So why it matters is because you have a different security configuration across the catalog. So basically, when you define a security configuration on this catalog, you have to apply again the same security on another catalog to have consistency. So the purpose is really to have a single catalog that avoids duplicating the security across all these catalogs. So the purpose is to avoid inconsistencies and a single security layer. So that's why basically the Iceberg REST spec has been created. So the Iceberg REST spec is something that the REST client is implemented using different language. So you have Iceberg, Iceberg Java, Iceberg Python, Iceberg Rust, Go. That create a REST client which support any catalog that implements the REST specification. So it means that it's basically the same storage, the same catalog, the REST catalog, used with different language. And so that's something that Polaris implement. So remember, the Iceberg REST specification is just a specification. There are no engine, no runtime provided in Iceberg to implement this REST specification. So you have different implementation of this REST specification. Apache Polaris, it's an implementation of this REST specification. So basically, Polaris is a REST catalog. And so the two purpose is really cross-engine interoperability. So it means that you can use any engine supporting the REST spec, the Iceberg REST client can work with Polaris. It's also centralized and cross-engine security and access. So it means that instead of duplicating your security across different engines, you just define in Polaris, and all the engines gonna use the security layer defined in Polaris. And finally, it runs anywhere. So you can run locally on your machine, you can run on Kubernetes, you can run on a single Docker. It doesn't really matter, it runs anywhere. So the first thing is about security and access. So basically all about users, principal, and roles are defined in Polaris, and all query engines going to use this Polaris layer to get the airbag management. So basically Polaris is responsible to, depending on the roles you define, and considering a query engine, it give access or not to basically the tables and data. So you have a role-based access control defined in Polaris. So all the management is of this role principle is made in Polaris, and then this we have a credential vending to basically delegate the credentials to the from the engines to the data. So that's one the first purpose of Polaris is to have cross-engine security and access. Also, the interoperability, so any engine supporting the Iceberg REST protocol can work with Polaris. So if you take Trino or Dremio or Spark or Fling, you just configure the REST catalog endpoint, and then it's gonna work out of the box. You don't have to define any adapters or whatever. It's simply using the Iceberg REST client. It runs anywhere. No looking. So we provide Docker images. We provide Helm charts allowing you to deploy on Kubernetes. So there are no requirements in terms of infrastructure you need to run Polaris. It's pretty flexible because it means that you can deploy Polaris on AWS, and then you can move to another infrastructure without changing your airbag namespace or table definitions. So this is an example of a secure query execution using Polaris. So I have a query engine, which is Spark, and this query engine is used by a user named Alice. And so Alice is basically run a query to read data from table one. So table one is on Iceberg. So the first thing that Polaris is gonna do is to verify that Alice has access to table one. This is this step. So basically Polaris know the roles, know the tables, and check, okay, this role is able to access this table, yes or no. And then Apache Polaris generates credential for storage and do a vending to basically the S3 location to access the table 1 data. Then if a permission, okay, Spark reads the table from S3, and then you get basically the data returned to Alice. So that's exactly where the security configuration is shared across all the engines. Something which is pretty fine in Polaris is actually the notion of catalogs. When you start Polaris, you don't have any catalog yet. You have to create at least one catalog in Polaris. So it means that a single instance of Polaris can host multiple catalogs. And we have two kinds of catalogs. We have internal catalogs, so the one created and hosted by Polaris, and we have external catalogs, meaning that you can access all the catalogs outside of Polaris, but the metadata comes into Polaris as they are locally on Polaris. So in Polaris, you create catalogs, and then inside the catalog, you create namespaces, tables, etc. The namespaces and table and views are defined by Iceberg entities. So, but nothing is hard-coded there in Polaris. You can create your own entity if needed, but by default, we match to the Iceberg entities. In terms of permissions model, you have basically two kinds of permissions. You have the one you define across catalog, so at Polaris level, and you do a mapping between a role you define at Polaris level with a role you define inside a catalog. So basically, the principle there represent the application or users. They are global to all catalogs defined in Polaris. Then you create principal roles. It's a group of principles. And again, like the principal, they are basically global to all catalogs hosted in the Polaris instance. And then you do a mapping between this principal role and a catalog role. So basically, you can share the same principal role with different mapping in the catalog. The reason is, doing that, it allows you to implement things like that. So for instance, I'm JB. This is my principal. I'm on two teams, engineer and data team. And you can see that the data team role, which is global in Polaris, have two kind of mapping. The first mapping, it maps to the catalog reader role inside my clickstream catalog. And it maps to add browser role into my 3P apps at catalog. So you can see that without changing the role at global level, you can have a different mapping. And so you can define, okay, in this catalog, this role will have read data, write data, list table, list namespace permission. And in another catalog, I may have another name and I may have different permissions. So in terms of roadmap in Polaris, that's different ideas we are discussing. The first idea is to have a kind of federated catalog. So basically, the purpose is to gather all catalogs in one Polaris catalog. So it means that using external catalogs, we can imagine to have NESI, Unity, any catalog that support the Iceberg REST API, loaded into a single Polaris catalog. Especially for transition purpose, it's pretty fine because it means that you can have a single catalog basically delegating the metadata to some sub-catalog and external catalog like Unity, for instance. Some ideas we are discussing about changing a little the runtime with a better plugins mechanism. So today Polaris is powered by Drop Wizard as a framework. We are discussing about evaluating Quarkus as an alternative. The purpose is really to improve the plugins mechanism. The reason why we want to improve the plugins mechanism is basically we want to have more pluggable layer in Polaris. For instance, today, the role-based access control that I show you, the model, is basically hard-coded in Polaris. So all the principal, the layers, extra is hard-coding. It means that in some cases, we want to use a different model. So we need something more pluggable there to allow you to change the current airbag and use another model. So for that, we need a plugin mechanism where we can easily load the airbag model when needed. Another idea is to have column-based and row-based access control. So today the granularity is only on tables. So basically you can say, remember my example using Alice and Spark. Today Alice and Spark can just define, okay, this is an access to the whole table, table one, yes or no. Maybe I would like to define, okay, Alice can access to table one, but only column A, B, and C, not D, or maybe also on role-based access control. So that's more granularity in terms of access control we define in Polaris. Another idea that we are discussing is most of the time in Iceberg, we need to do some tables maintenance. So basically, when you insert a lot of data in Iceberg, you need to do compaction, you need to do vacuum. So basically, when you remove data in Iceberg, it's not actually removed, it's stored in the delete files, could be equality or positional delete. But it means that at some point we want to compact the data files, but actually deleting the data in the data file. So meaning that we have to rewrite the data file. So this should be done by a query engine because the query engine is most of the time highly distributed and scalable. So the purpose is really to be able to plug a query engine into Polaris because Polaris knows when a table needs a maintenance because he stores the metadata, he knows the metadata, so he can say, okay, this table may need a compaction. This table may need, I don't know, a garbage collection. But so he knows, but he should not do it by himself. So it means that a query engine can subscribe to Polaris on a dedicated endpoint, and then Polaris can notify the query engine, hey, you have to do a compaction on this table. So that's the kind of discussion we're having right now inside the Polaris community. Multi-table transaction, as I said before, when you insert data into a table, we have a new metadata added, so we have a new commit. But it makes sense to do that for multi-tables, not a single one. So multi-table transaction, it actually has been merged a month ago. So the first version is already included in the Polaris code base. That probably we can do more like a persistence transaction. Like if you restart your Polaris instance, maybe it makes sense to have a journal of transaction just to be able to resume the ongoing transaction, stuff like that. So the first version is in memory, it works fine, but maybe it makes sense to improve a little for recovery of transaction. That's a quick introduction about Polaris and Iceberg. If you have any question, please let me know.
Okay. Again, if anyone has any questions, please put them in the Q&A box at the bottom of the Zoom screen. We'll give 30 seconds to see if there's any questions. But yeah, like but how has been sort of like I know, has there been any like very recent additions to Polaris and like recent releases in the last couple weeks?
Yeah, so we are discussing about so the first release is going to happen pretty soon. It's going to be mostly a validation release from an Apache standpoint. So we discussed about releasing Polaris 09, 0.9. That should be the first one. The first thing that I want to say is Polaris is production ready. So you can already use it, build it. We don't yet have any package available, but you can already download it, build yourself, and it just works. In terms of releases, 09 is going to be for end of, I would say current November, to be honest. Because we have it's going to be the first release at Apache, and we know that it takes time to validate every every legal aspects, every package we provide extra. But I think Polaris 1.0 gonna be released before end of this year. That's basically the idea.
Got it. Cool. Let's see any other questions. And basically, when do you think, like, how's the conversations going specifically, like, let's say about the pluggable security layer, like how's like or some of the stuff that you put on the roadmap, like when would you think we'd probably have more clarity on sort of like what the direction would be?
Yeah, that's a good question. We had the first community Polaris community meeting last week where we discussed about some of these key changes we plan to bring to Polaris. We have sort of agreement where we want you to go. For instance, airbag pluggable mechanism is already mostly, we have a kind of consensus. So now we have to implement it, and we love contributions. So if you want to contribute, anyone can contribute for sure. It could be documentation, it could be code, it could be a test, it could be whatever. So yeah, we have a lot of work ahead. So yeah, pluggable airbag is already on the consensus. Table maintenance with a notification layer, it's almost also a consensus, but I think that it's something that we can also discuss within the Iceberg community, because it could be something that we can see in the REST specification directly, not only in Polaris. Um, the idea is really to use Polaris as a kind of experiment for this kind of endpoints. And if we have some kind of, okay, this is interesting, not only in Polaris, but could be interesting for any query engines using the REST client, then it should go into Iceberg. My point is, that's my personal vision. Everything about table and query engine, which is global to the Iceberg tables and view, should be on the REST spec. The rest, like table maintenance, like extra, is not directly a REST spec thing. It's really a Polaris. It's really a catalog implementation details, but it's not a detail. But specific.
Agreed. Okay. Awesome. Let me just take one check to see if there's any other questions. But no, I mean, first I want to say is JB, thank you for coming on to Gnarly Dataways. We look forward to having you on again soon. Now, for any of those who are in Europe by chance, me and JB will be speaking in London and in Paris next month. So head over to dremio.com/events and keep an eye out for the details for those events. Hearing us talk about Iceberg, Polaris, and all sorts of other really great lakehouse technologies. And if you don't already follow JB on LinkedIn, please do. Anything else you'd like to mention, JB, before we wrap up?
No, thanks again for the invite, Alex. It was a pleasure. And again, we love contributions. So if you have ideas and things you want to contribute to Polaris, just go to polaris.apache.org, take a look on community menu, and start to contribute.
That's right, everybody. Go make your Polaris forks and make some contributions. Thank you very much, JB. We'll see everybody. We'll see you all next time.
Thanks, Alex. Thanks all. Cheers.